In Module 1, Lesson 13, we're going to do a little bit of review, and we're going to take a look at those division problems where we model with a tape diagram. And as we saw in the last couple of lessons, you can do that when the unknown is the number of groups, or you can do that when the unknown is the size of the group. So today we're going to tackle both of those sorts of problems and see how those tape diagrams look. It's going to be a review, but it's an important review and really a good time to make sure that we have those skills. And make sure that we're understanding what information we know in each problem and what information we don't yet know and that we need to solve for. So let's take a look at the two problems I have ready for you and see how we go about this. The first one says, a class is working in groups on a project. There are 18 students total. Each group has 3 students. How many groups does the teacher need to make? So the first thing I'm going to do is I'm going to go through and I'm going to highlight the information that I already know, because that really helps me. So I have 18 students total. And I have, each group has 3 students. I'm not gonna underline that first part where it says each. And then in a different color, I'll say how many groups. So I know there are 18 kids, and I know that there are 3 kids in each group, and I don't know how many groups I need yet. So here's what that sort of looks like. 18 total divided into groups of 3 equals, we don't know, number of groups. That is what we're going to figure out. Okay? So if you take 18 total, divided into groups of 3, you don't know the number of groups yet. That's what you're going to figure out as you go. And one way to do that is to use a tape diagram, like we've been working on the last couple of days. So we can get that set up, and we can put a bracket down here. And we can say that there are 18 total students. And the reason I can already say that is I know that there are only 18 kids, exactly 18. So all of my kids are going to fit inside this rectangle. And I know that that number is going to come out to 18 when I'm all done. The part I don't know is the, put a comma where I didn't need one back there. Let's get rid of that. I don't know the number of groups. And another piece of information I do know is I know that each group, or one group, is worth 3. So I'm going to draw a line right in here and say that this shows 3 kids. I'll put it in here. You don't have to put them in these white spaces, but I will, just to show you that there are 3 there. It's perfectly fine just to label it up top. That's the more efficient way, especially as we get into more complex problems. But then I can go ahead and I can, if that group is 3, if that unit's 3, this is also 3. So I know I have to get up to 18. I'm going to group count by 3. So 3, 6, 9, 12. And then I'm going to divide this last box and make it into 2, 3, and 3. So now I have 3, 6, 9, 12, 15, 18. So in making these units all the same size, all groups of 3, I have 6 groups, and 6 times 3 is 18. So I know that I have 6 groups, 1, 2, 3, 4, 5, 6. And I can write this like 18 divided into groups of 3 equals 6 in each group. And let me label that for you. I'll do it in a different color just to mix things up. 18 again is your total. 3 is the size of the group. And 6 is the number of groups. So that's one type of problem we do. And that's where you know how big each of these units or each of these boxes is going to be to start off. And what you're trying to figure out is how many of those boxes do you need to fill up the big rectangle. So again, when you have something and you know the size of the group, that means you know what to label this right here. My drawing tool didn't work there. you know what this is at the start, you know how big to make that. And then you can just keep making copies of it until you fill up the big rectangle. Make sure that you have the total, equal the total number of students or total number of objects you have in your problem. The other type of problem is sort of the opposite of that, where you don't know the size of the group, but you do know how many groups there are. So one like this, it says, Mr. Brunel and Mrs. Mayo's classes are going on a field trip. There will be 30 students on the trip and they'll travel in 3 vans. How many students will ride in each van? So we'll go through here again and we underline, that's really helpful. So 30 students, that's my total. And they'll travel in 3 school vans. So that's the number of groups. And I'm going to separate you into 3 different vans, 3 different groups. And then the thing we don't yet know is how many students will ride in each van. Well, that right there is the size of the group. So I have, let's see, 30 students, my total. I'm dividing them in or putting them into 3 vans, 3 groups. And that's going to equal, we don't know yet, but it's going to equal some number per group. So again, that's the size of the group. That's the number of groups. And this over here on the far left is the total. And we can still use a type diagram to solve this sort of problem. So let's go ahead and do that. We'll start by drawing a big rectangle that represents my total number of students. So all 30 kids are going to fit in there. This is my whole field trip going group here. 30 students. And we already know that they're going in 3 groups. So I can put that here too. Oops. Click the wrong button there. Let's just undo all of that. So 30 students going in 3 groups. Well, since I know that there's 3 groups, let's go ahead and divide this up. I can make, this is like van 1, van 2, and van 3. So at this point, there's a couple of different ways to go about this. And in this problem, I would probably expect you to do something like, well, I can count by 3s to 30, or I just know that if I count 3 times by 10, I'll get to 30. That's sort of what I'd expect for this problem. You could go 10, 20, 30. Oh, well, that's 3 groups right there. So there must be 10 students in each. Or you can do it in a different way if you need to. Let me show you what that might look like. Again, you also could have counted by 3s, gone 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Said, oh, I just counted 10 times by 3. The answer's 10. Or you could do something more like this. You could say student 1, student 2, student 3, and go back to the beginning. 4, 5, 6. And you're going to keep doing this all the way up till 30. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, whoops, 21, 22, 23, 24, 25, 26, 27, and 28, 29, and 30. And now you can see in there that I have 10 students per group. 10 students. So now that and again, you don't have to do that for every problem, but if you get stuck, you can do it that way. It takes more time. It's not as efficient, but it's a way to solve a problem if you get stuck or if you're unsure of what to do. I can go ahead and rewrite my problem now with 30 divided into 3 groups equals 10 per group. And this is my size of group. And this is my number of groups. And again, the 30 is the total or the starting number. So the total number of students. in this lesson, these are the types of problems you're going to deal with. And again, it's a review. It's something we've done before here in the last couple of lessons, but it's great practice because, again, tape diagrams are not new to you, but using tape diagrams in division are, and using tape diagrams in multiplication is new to you. So it's great to have additional practice, and it's great to really go through the exercise of understanding what you know in each problem and understanding what you need to find out. And these types of problems give you wonderful practice in that. I say every time, if you have any questions, please let me know. And that's still true. So if you're not sure how to do something, please ask and I'll be happy to answer it for you. Thank you guys. You're doing a great job. You're working really hard and I appreciate all the effort that you're putting into your learning.